May peace be on all of you. Myself, Dr. Majid Khan, Associate Professor Loknete, Dr. J.D. Pawar, College of Pharmacy, Kalwan, Nasik. I welcome all of you in Diuretic chapter. In previous lecture, that is in lecture 1, we were covered the osmotic diuretic and carbonic anhydrase inhibitor. Now in this video, that is in lecture 2, we will cover thiazide diuretic. So it is an important class of diuretic, that is thiazide diuretic. An exam short note may ask about the thiazide diuretic. So now let us start. Thiazide diuretic. Here the chloraminophenamide is a key intermediate in development of diuretic that lack undesirable property of CA inhibitor. When chloraminophenamide was treated with acylating agent or acid or aldehyde or ketone, yield 1,2,4-benzothiazine 1,1-dioxide and corresponding dihydro derivative respectively. The product of which this reaction is called as thiazide and hydrothiazide respectively. So here is, if you see the synthesis or chemistry of thiazide diuretic, here the starting material is chloraminophenamide. So when this chloraminophenamide is treated either with acylating agent or aldehyde and ketone, then it gives the 1,2,4-benzothiazine. It is a 1,2,4-benzothiazine 1,1-dioxide. So it is a 1,1-dioxide. So it is a general name of this compound is 1,2,4-benzothiazine 1,1-dioxide and corresponding dihydro derivative, and this type of compound is called as thiazide. So it is a thiazide. So if we see the mechanism of this reaction, so chloraminophenamide when treated with acylating agent, then it forms the thiazide. Same compound is treated with aldehyde or ketone, then it forms the hydrochlorothiazide. So it is a reaction how chloraminophenamide is converted into thiazide and hydrothiazide respectively. So if we see the uh, formation of thiazide diuretic by using chloraminophenamide when treated with acid chloride. So here it is a chloraminophenamide which is a starting material when treated with acid chloride. So here see the mechanism. So here the lone pair of this NH2 attack to this carbonyl carbon. Here there is a removal of HCl minus HCl. Hydrogen is removed from here, Cl removed from here, and there is a formation of bond between these two. So like this. So first step, attack of lone pair of NH2 on this carbonyl carbon. Hydrogen from NH2 is removed, Cl from acid chloride is removed. So it forms this type of product. Then lone pair of this above NH2, this NH2, then attack to this again carbonyl carbon, then it become O minus. So like this, there is a O minus. Then hydride transfer from this NH2, hydrogen transfer here, it become OH. So like this OH. Last step, removal of water molecule. So hydrogen from this NH is removed, bond shifted here, it become double bond in ring, and OH is removed. So total water molecule is removed, it forms the product called as thiazide. So it is the conversion of chloraminophenamide when treated with acid chloride, it forms thiazide. Again reaction mechanism repeated. NH2 group of lone pair attack to this carbonyl carbon. First step, removal of HCl, hydrogen from NH2, Cl from here minus HCl. Then lone pair of this nitrogen attack to again same carbonyl group, it become O minus. Then hydride transfer, hydrogen from NH2 transfer here, it become OH. Removal of water molecule, hydrogen is removed, this bond shifted here, it become double bond in ring, OH minus. Total H2O water molecule is removed to form the thiazide. Similarly, formation of hydrochlorothiazide. It is a hydrochlorothiazide. Difference between thiazide and hydrochlorothiazide is the only difference of double bond. So in case of thiazide, if you see, here is double bond, but in case of hydrothiazide, there is a single bond. So here the starting material is same, that is chloraminophenamide, but here there is a formation react with formic acid. It is a formaldehyde. Sorry, it is a formaldehyde. So mechanism again same, NH2 group attack to this carbonyl carbon, but here it become O minus. So like this O minus. Then hydride transfer from this NH2, one hydrogen is transfer here. It become OH, like OH. Similarly, here lone pair of this NH2 attack to this carbon. So here there is a formation of bond and development of positive charge on nitrogen. Then a removal of water molecule. So here hydrogen from this NH2 is removed, OH from this removed. So hydrogen is removed, this OH is removed, and bond shifted here. Sorry, nitrogen positive charge is neutralized and this OH is removed. So it forms the hydrochlorothiazide. So again, mechanism action in lone pair of nitrogen attack to this carbonyl carbon, it become O minus. Then hydride transfer from this below NH2 group, it become OH. And here simultaneously this lone pair of this nitrogen attack to this carbon here, so nitrogen bearing positive charge. Then removal of water molecule. So hydrogen from this NH2 group is bearing positive charge, hydrogen is removed, charge is neutralized, and this OH is removed. So total water molecule is removed, but there is a no formation of bond here because here nitrogen having the positive charge. So positive charge is neutralized by removing this hydrogen. So it forms the product hydrochlorothiazide. So it is a formation of thiazide and hydrochlorothiazide from this starting material chloroaminophenamide drug. If we see the SAR of this thiazide diuretic, so here prototype of drug is chlorothiazide and hydrochlorothiazide. So as we seen, chlorothiazide is prepared from the chloroaminophenamide by reacting with acid chloride. Chlorothiazide is the simplest member of this series. Similarly, hydrochlorothiazide is prepared from the reaction between chloraminophenamide with aldehyde. So chlorothiazide, which is a simplest member of this series. So it is a structure of chlorothiazide. Here is Cl is present, therefore chlorothiazide. So first point in SAR, NH group at position 2, this one. So it is a NH at position 2, numbering start from here 1, 2, 3, 4 like this. So NH at position 2 is more acidic because electron withdrawing effect of neighboring sulfur group. So this hydrogen at position 2 which is attached to nitrogen is more acidic because this SO2 group is more electron withdrawing effect. Sulfonamide group means this on 7th position. This is a sulfonamide group. Provide additional point of acidity in molecule. So here also hydrogen is there. So this hydrogen is also acidic. So this hydrogen is also acidic. This hydrogen is also acidic. But acidity of this hydrogen is more as compared to acidity of this hydrogen. Therefore, this hydrogen, that is hydrogen which is attached to nitrogen at position 2 is more acidic, and therefore it utilized to prepare the salt. So when we treated the chlorothiazide with NaOH, then there is a formation of sodium salt. So this hydrogen is more acidic, therefore easily removable, and sodium is attached here, it becomes the formation of salt. So when hydrogen from position 2 is treated with NaOH, there is a formation of salt. So this hydrogen is utilized in formation of salt. This hydrogen is more acidic as compared to sulfonamide hydrogen. So it is the first point of SAR. Second point, saturation of double bond of chlorothiazide to give hydrochlorothiazide, which is 10 times more potent than chlorothiazide. So here in case of chlorothiazide, here is double bond, but if you remove the double bond from the chlorothiazide, then it forms the hydrochlorothiazide, which is more potent as compared to chlorothiazide. So the difference between chlorothiazide and hydrothiazide is only absence of this double bond here. So from chlorothiazide structure, if you see the here, it is a chlorothiazide. So if we remove this double bond, then it forms the hydrochlorothiazide, which is more potent than chlorothiazide. Next step, next point, electron withdrawing group at position 6 is for important for diuretic activity. So it is a sixth position. Numbering start from here 1 2 3 4 5 6. So electron withdrawing group at position 6 is required for activity. Little diuretic activity is seen when hydrogen is there. So if we here there is a no electron withdrawing group, then compound show less diuretic activity, where the compound with chloro, trifluoromethyl are highly active. So here on position 6 there is a electron withdrawing group for more activity. If there is a no electron withdrawing group, then activity is less. So example is hydrofluomethazine, which contain CF3 on 6th position. Therefore it is more active than the compound which does not contain any electron withdrawing group on this position. Next point, substitution with the lipophilic group at position 3. So it is a position 3. Here is benzyl group, which is a lipophilic group. Marked increase in activity and longer duration of action. So here it gives a longer duration of action because on third position there is a lipophilic group. Therefore it shows the longer duration of action. Example is bendrofluozide. So here the example is bendrofluozide, which contain lipophilic group. It is a benzyl group on position 3. Next, similarly, cyclopenthiazide having cyclopentyl methyl group. So here again on same position, third position, there is a cyclopentyl methyl group, which is also lipophilic group. Therefore it show more activity. The drug name is cyclopenthiazide. It is a cyclopenthiazide. So the point is, on position 3 there should be lipophilic group, which give the longer duration of action. So in case of bendrofluozide, benzyl group is there on third position, and in case of cyclopenthiazide there is a cyclopentyl methyl group. So both are longer duration of action. Then alkylation of position 2 increase the activity and duration of action. So here there is a alkylation. So here there is a alkylation at position 2, which increase the activity as well as duration of action. Example is polythiazide. So here there is a polythiazide which contain CH2S CH2CF3 group. So it gives the more activity and more longer duration of action. So it is about the SAR of thiazide diuretic. Now regarding mechanism of action. So as we seen in previous slide, there are 4 sites where all diuretic act on nephron. First site is PCT, proximal convoluted tubule. Second is ascending loop. Third one is distal convoluted tubule, and fourth one is collecting tubule. So here thiazide act on third site, that is distal convoluted tubule. So in site 3, that is in distal convoluted tubule, reabsorption of sodium and chloride by sodium chloride co-transport system, or called as sodium chloride symporter. So it is a sodium chloride symporter. It is a blue pump, like a pump. It is a sodium chloride symporter, or called as sodium chloride co-transport system. This system moves luminal fluid sodium downhill and luminal fluid chloride uphill into distal convoluted tubule cell. Reabsorption of sodium is completed when member-bound sodium potassium ATPase actively pump sodium in interstitium. About 5 to 8% filter load of sodium is reabsorbed. So here there is a distal convoluted tubule. This one is lumen. This one is tubule cell. This one is interstitium, inner part. So here the transporter is sodium chloride symporter. The function of this is it reabsorb the sodium along with chloride. So here the sodium and chloride is reabsorbed, and this process is complete when this sodium, which is reabsorbed from the luminal fluid into cell, this sodium is again transported to interstitium by the sodium potassium pump. So normally by this pump, sodium chloride importer, sodium and chloride is transferred from the lumen into the cell, and this sodium again transport to from cell to interstitium by sodium ATPase pump. So the mechanism of action of thiazide diuretic is that this thiazide diuretic simply block this symporter, that is sodium chloride symporter. So the thiazide drug act on sodium chloride co-transport system and block reabsorption of sodium and chloride with water. Similarly, it also inhibit sodium potassium ATPase pump. Thiazide also have some carbonic anhydrase activity, and hence some drug act on site 1 and site 4, which causes loss of potassium and bicarbonate. Hence, thiazide referred as natriuretic. Natriuretic means which causes loss of sodium. Chloruritic means which causes loss of chloride, and kaliuretic means which causes loss of potassium. So thiazide diuretic causes loss of sodium, loss of chloride, and loss of potassium. So simply thiazide act on this sodium chloride symporter and also act on sodium potassium ATPase enzyme and inhibit this pump. Therefore the reabsorption of sodium along with chloride along with potassium is inhibited. Therefore more sodium, more chloride is excreted through the urine. Thiazide also have some carbonic anhydrase inhibitor activity. Therefore it also causes loss of potassium. So overall thiazide causes loss of sodium, chloride and potassium. Therefore it is called as a natriuretic, chloruritic and kaliuretic. So it is about the mechanism of action of thiazide diuretic. Now individual drug, if we see the individual drug with their IUPAC, so it is the first drug chlorothiazide. So if we see the IUPAC name 6-chloro, so here 6-chloro means this 6-chloro. So here is 6-chloro. Then 2H means here is 2H. Benzo means this benzo group. This one is benzo group. E, this small e means if we give this numbering alphabetically. So here is a small a, here is B, here is C, here is D, and this one is E. So if we give the name ABC, again this bond is A, this bond is B, this C, this D, and this one is E. So therefore it is E. Common bond is E. So here this is common bond. So it is a common bond which is attached through this ring. Therefore it is called as E. This one is E. Benzo means this benzo. 1, 2, 4. So here is 1 sulfur is there, 2 nitrogen is there, and 4 also nitrogen is there. So 1, 2, 4 thiadiazine. Thia means sulfur, dia means 2, aza means nitrogen. 1, 2, 4 thiadiazine. 7 position there is a sulfonamide group, 7 sulfonamide. On 1 position oxo 1 dioxide. So 6-chloro, 2H, benzo, in bracket E. E means this common bond. Keep in mind this E. There is a common bond between these two rings, so it gives E. This one is A, this bond is A, this bond is B, this bond is C, this bond is D, this bond is E. So therefore small e. Then 1, 2, 4 thiadiazine, 7 sulfonamide, 1, dioxide. Second drug is hydrochlorothiazide. Here same, only the difference is there is no double bond here. So 6 chloro, same. 3,4 dihydro. So here there is a no bond, therefore 3,4 dihydro. 2H is same. Benzo is same. Small e same. 1,2,4 thiazide is same. 7 sulfonamide 1,1 dioxide is same. So only difference is here there is a no double bond, therefore 3,4 dihydro. So I pick name 6 chloro 3,4 dihydro 2H benzo E 1,2,4 thiazide 7 sulfonamido 1,1 dioxide. Next drug is hydroflumetazide. Hydroflumetazide. So here again numbering pattern is same 1 2 3 4 5 6 7. So here on 6th position there is a trifluoromethyl. So it is a 6th position trifluoromethyl. 3,4 dihydro. So again here there is a no double bond. So same 3,4 dihydro. 2H means same 2H. Benzo again same benzo. E again same E. This bond is common bond E. 1,2,4 thiazide same 1,2,4 thiazide 7 sulfonamido 1,1 dioxide. So 1,1 dioxide. So approximately same. I have picked name, only the some differences there. Here is CF3 on 6th position. So therefore I have picked name is 6 trifluoromethyl 3,4 dihydro 2H benzo small e 1,2,4 thiazide 7 sulfonamide 1,1 dioxide. Then common uses of thiazide diuretic. Thiazide diuretic are primarily used to treat hypertension, that is high blood pressure. Edema means swelling, accumulation of fluid caused by water overload, as well as certain conditions related to unbalanced calcium metabolism. Precaution is necessary when these drugs are co-administered with cardiac glycoside, because these drugs tend to promote hypokalemia condition that enhance the general toxicity of cardiac glycoside. Therefore, in pharmacology, the question asks thiazide and cardiotonic is used with precaution, because in case of cardiac glycoside it also causes the loss of potassium, because cardiac glycoside inhibit the sodium potassium pump. Therefore it also causes the loss of potassium. Similarly, thiazide also causes the loss of potassium. So if we given the cardiac glycoside along with thiazide, there is a heavy loss of potassium which may be dangerous. So therefore thiazide and cardiac glycoside given very precautionally. Combination of thiazide with potassium sparing diuretic may prevent potassium loss in these circumstances. So thiazide if we given with potassium sparing diuretic, this category we will see in next lecture. Potassium sparing diuretic means which causes or which preserve the potassium within the body. So this potassium sparing diuretic not causes loss of potassium, but it preserves the potassium in body. So therefore thiazide when given with potassium sparing diuretic, there is a no loss of potassium. So it is the main uses of thiazide. So it is about the thiazide diuretic. If you like the video, subscribe the channel. In next video, that is in lecture 3, we will see loop diuretic and potassium sparing diuretic. So if you like the video, then subscribe the channel. Thank you very much.